So beginning with 10 here, find the p-value for the hypothesis test with the standardized test statistic z. Determine whether to reject h0 for the level of significance alpha. Okay, so we've done some hypothesis testing, and we have our z value there, and we have our level of significance. All right, so we know this is coming from, since we're using z, this is coming from a hypothesis test where we knew the population standard deviation, although it's not shown here because the work has been done. But what we need to do is figure out the p-value. We are being told it's a right-tailed test. So what we're looking at based on this z-value and the right-tailed test is this. Call that 0.52 for our z-value, and so we're looking at this area here. Okay, so that means that we're going to have to find this area to get, which is going to be our p-value, and then we'll compare it with the alpha. Now remember, when we look up a z-value using Excel, then we're actually going to get this area. So we're going to have to take that area here and subtract it from 1 in order to get the area over here that we want. Okay, so let's go to Excel. So I'm going to do equals norm dot s.dist, put in my z-value 0.52 and put in true so that I get the cumulative there, and that gives me 0.6985, and if I do equals 1 minus that, I have 0.3015. And this is indeed the number that I want right here. So that is the area I'm looking for, and that's going to be my p-value. Okay, so if we go back, we found that this area was 0.6985. But the 1 minus 0.6985 gave us 0.3015, and this is the value we want. So that's going to be our p-value. We have our alpha of 0.05 given over here. That's alpha. Compare it. Well, 0.3 is definitely bigger than that. And if we have a p-value that's bigger than our alpha, then we fail to reject. So there's our p-value, fail to reject. Okay, so now we're back up. We'll back up another step, test the claim. So now we're back to having the claim and alpha. Look, we do know sigma. This means this is going to be a z-test. Okay, we have our sample statistics there. Okay, so we need to do about everything here. We need to go and set up the null and alternative. Here's the claim. It's mu greater than 22, so that has to be alternative since it does not have the equals. So mu less than or equal to 22 is there. We also see that because this alternative is mu greater than 22, that this is actually a right tail because it's the value being greater than something. Okay, so what do we need now? We need the z-value, all right, because we know x bar, but we need to get that into z. Well, that's just z equals x bar minus mu over sigma over the square root n, which would be 22.3, which we were given, minus the 22 that we're assuming over the sigma 1.2 given and square root of 50 being given. And you do that, you're getting approximately 1.77. So that is the z value here that we're at. So let's see. Now we need to find what the area and hence the probability for this region is. Okay, so we're going to have to go back to Excel here. All right, so let me get rid of all this. And again, we're going to have to do that left area and then subtract to get the right area. So this was norm.s.dist. I have 1.77 true. That's the left. So then I have to do 1 minus this. 0.0384, let's call it 0.0384. All right, 0.0384. So then we take this 0.0384 and we're going to compare, that's our P, compare that to our alpha, which is 0.05. 0.0384 is less than 0.05. When you have a P that's less than alpha, your decision is reject H naught, the null hypothesis, because that you found that this was a very small probability compared to your significance, and so we reject. Now, how do we make our interpretation from this? Well, the claim was in the alternative, meaning we're in support mode. So we rejected H naught, bringing us to our claim. So there is enough evidence at 5% significance level to support the claim. Good. All right, let's do another one. Fast food outlet claims the mean waiting time in line is less than 3.4 minutes. Random sample of 60 customers. Okay, mean, standard deviation. Test the claim. Okay. So let's set it up. Mean waiting time in line is less than 3.4. Mu less than 3.4. That's the claim. Doesn't have an equal, so it's in the alternative. Mu greater than or equals to 3.4 is the null. And this would be a, based on this alternative we look at, this is a left tail because of the less than there. All right, so again, we need our, well, what is the test statistic for this one? Well, we have a population standard deviation of 0.6. That's a sigma. So we know the population standard deviation, so this is a z-test for one sample. Okay, so I need my z-value, x bar minus mu over sigma over square root of n. So that's going to be x bar, mean of 3.3, mu, we're assuming 3.4, over sigma, that was the 0.6, over the square root of, there were 60 customers. Okay, so this will give us approximately negative 1.29. So this is negative 1.29 over here. That's the z value. So, I need to find this area here, this probability slash area. And so I need to go back to Excel. This time I don't need to do any subtraction because I'm doing a left area. Okay, so but I do need norm.s.dist, negative 1.29, true, 0.0985. Okay. 0.0985. Okay, so 0.0985 is our P. 0.05 is our alpha given. This is bigger. This P is bigger than that alpha. Fail to reject H0. Okay, and since the claim was in the alternative, this is a support mode, we were not able to get to the alternative, so there is not enough evidence at the 5% significance level to support the claim. Still a support one because the claim was in the alternative, but I failed to reject the null, so I didn't get to the alternative, so there's not enough evidence at the 5% significance level to support the claim.